In this video, we will be talking about the Born-Haber cycle. And that guy Haber, is a very famous chemist. He invented two really famous things. One, chemical warfare during World War I in Germany. And two, he invented a way to process nitrogen in the atmosphere into ammonia, which is useful for, again, warfare in terms of making gunpowder and explosives. And also we use it now to make fertilizer. So that's just an aside. So let's look at a simple reaction. Again, going to stick with sodium chloride. So we have sodium solid reacting with 1/2 chlorine gas to give us NaCl. And I know we normally don't have the 1/2 here, but it's simply so we can get a 1. This is a solid. It's simply so we can get a 1 coefficient in front of the sodium chloride. We're doing thermochemistry now that we've talked about that. But in thermochemistry, we often, we want to get just 1 mole as the product. Okay, so that's why you see the 1/2 there. So this is a redox process, as we've talked about. Sodium transfers an electron to chlorine, or you could say chlorine takes it from sodium, either way. And what we end up with is a sodium chloride lattice. However, this process, that transfer of electrons, doesn't explain the energy release, because this is a very exothermic reaction. And exothermic we'll talk more about. That just means it releases energy. Okay? And you may know that already. So we have to figure out where the energy is coming from for this process, and that's what the Born-Haber cycle allows us to do. And we're going to draw kind of a little table or graph. And just kind of a long line along the bottom, and then we're going to draw a few lines going up. And it's not going to make sense why I'm doing this, of course, but hopefully it will as the process moves forward. Okay, so this first step, I want to move that one up. This first step is the overall net reaction. Okay, and that overall net reaction is just what we have written above. We have sodium solid plus 1/2 chlorine gas gives us NaCl solid. And that is a decrease in energy. So I'm going to put an arrow going from this line down to here. Okay. Again, you don't really have to understand why I'm doing this right now. It's the way the process works. Okay, I'm going to draw another line up here, and then a little bit down below that, I'm going to draw another line here. Now, this gap here this is our lattice energy step. So remember, for a lattice energy, we have gaseous ions coming together to form the solid. Notice both of these reactions end in NaCl solid, and they end at the same place energetically, okay, down here at the bottom, down on this line down here. So let me just label these a little bit better. This is the lattice energy. And for this process, so this reaction, and every single reaction is different, we have negative 787 kilojoules per mole. This one over here, this is our net reaction. and that has a change in energy of -1, I did it again, 411 kilojoules per mole. Okay. So if we look at this process, you'll notice these two reactions are not the same. They have the same product, but they don't have the same reactants. And what the whole idea behind this process is to get this sodium to look like this sodium, and to get this chlorine to look like this chlorine. Okay? So basically what we have to do is convert solid sodium into Na plus gas. And we have to convert 1/2 Cl2 gas into Cl minus gas. Okay, so let's go ahead and go through the process. And the first thing I'm going to do, I'm going to deal with sodium first. I'm not going to worry about the chlorine right now. Okay, so we're going to put another line. And this next step is simply going to be to turn the solid sodium into a gas. Remember, we're trying to get this sodium here to look like this sodium here. So the first thing I need to do is get it to the gaseous state. So Na solid going to Na gas. And that is called sublimation. And sublimation is simply turning a solid into a gas without going through the liquid phase. Okay? And that has an energy associated with it. And that energy is positive 107.3 kilojoules. Okay? And that's a positive, so the arrow goes up. Next, I'm going to talk about the ionization energy of chlorine. And so draw another line here, and my graph isn't necessarily going to be to scale. Don't worry too much about that. So we have sodium gas, but we need sodium plus gas. So next step is going to be Na gas going to Na plus gas. And what did we do? We lost an electron. This is the ionization energy. Okay? And that has an energy of 495.8 kilojoules. Okay, and all these things, oops, they're all kilojoules per mole. And all of these can be looked up. Okay, I'm not making any of these up. Next, okay, I'm done with chlorine, or sodium, excuse me. Because if you notice, now sodium looks exactly like I want it to. It looks exactly like that sodium there. Okay, so I'm done with sodium. I'm going to move on to chlorine. Now, this next step is a process we have not talked about. Okay, notice we have, in this overall reaction, we have Cl2, but here we have Cl. So I need to break the bond. Okay, I need to break that bond. So I have 1/2 Cl2 gas going to Cl gas. And this is called bond dissociation energy. And what does that mean? Dissociation just means to break or pull apart. So we're breaking this bond, and it's the energy associated with breaking that bond. Now to break a bond makes sense that it requires us to add energy. So let's put that energy in, and that is 122 kilojoules. Okay, now that is 122 kilojoules for 1/2 a mole of chlorine, because right here we have 1/2 a mole. Okay, so the bond dissociation energy for chlorine, when you look it up, would be double that. It would be 244. Alright, so I forgot to put my arrows in. These are both up because we're adding energy here. And now this last step, well, the last step, we're simply going to take the chlorine gas and we're going to add an electron to it. Make it Cl minus gas. And remember, this is electron affinity. Okay, and that has an energy of negative 348.6 kilojoules. Remember, those are always negative. Because it's negative, we have a down arrow. And so you can see we've completed the cycle. Chlorine looks exactly like we want it to. Sodium looks exactly like we want it to. There's our chlorine, matching that chlorine. And in the next video, I'll show you a different way to go about this.